Okay, today I'm going to look at at this article here. Zig-style generics are not well suited for most languages. Now, I haven't used Zig myself. Right now, I'm currently learning Rust and OCaml, so I have my hands full. But Rust is a language I do want to look into later. I find the data-oriented design approach very interesting, but also I kind of have my doubts about whether like Zig is a like it is the right approach in terms of how it wants to expose control flow as much as possible. Like C kind of. But anyway, that's a topic for a different day. What I want to see is how Zig style generics work because I heard that Zig doesn't use like C++ templates, and it doesn't use like whatever like Rust's template system is, which is kind of like C++ generics but just less powerful, I guess. And of course, it's not just macros like C uses. So yeah, I'm curious to not only see how Zig style generics work, but then also what this argument is for why other languages can't adopt them. So yeah, let's have a look. Just I guess to preface my understanding so far of Zig's type system. I mean, I haven't looked too deep into it, but I mean, not type system, generic system is that you can pass. Essentially, you can pass types as values, I think, um, and or use reflection to kind of figure things out, which is also interesting because C++ 26, I think, is adding reflection. So I wonder how that would also work as an alternative to the template system currently in C++. Anyway, the TLDR of this is that Zig's compilation scheme for generics shares a lot of similarities with C++, okay, and hence the pitfalls too, okay. Such a compilation scheme is not well suited to all languages, so armchair suggestions about how other languages should embrace Zig-style generics are misguided. Armchair suggestions. Ain't nobody handing out free lunches in generics land. Okay, okay, yep, let's just get into it. So I've seen one too many people claim that Zig's implementation of generics is somehow perfect and that other languages should copy it. Here's one such example from a recent thread in r/programming. Zig has just taken the path that all languages should have taken by now and decoupled generics from their type system so you don't end up with a bastardized language within a language that has weird, inconsistent rules and behaviors. Okay, so like the argument that like you can learn C++ and then just be rubbish at templates because like templates almost feel like their own language in a sense. And as far as I understand, C++ generics are Turing complete, so like they can literally function as their own programming language, however inefficient. And similarly, a similar argument is in Rust with the macro system that you also kind of need to like learn. I mean, I don't know how bastardized it is, but like you need to learn like another language within the language. Although I think macros might be more consistent, maybe. Um, whereas templates have their issues in C++. Zig saw that generics is literally just generating code at compile time and decided to ask, why on earth are we writing entirely separate Turing complete programming languages for this? Okay. This comment is sitting at plus 17 upvotes at the time of writing. Ah, I wish I linked it. This is just one example, but I've seen this repeated enough times that I got a little frustrated. Hence this post. Yes, I know. XKCD386 duty calls. What? Is that a reference? A webcomic of romance, sarcasm, math, and language. Are you coming to bed? I can't. This is important. What? Someone's wrong with it. Okay. it's just, it's just dropping a reference to a webcomic like that with like no link. Just putting it like as plain text. That is quite Sigma. Um. Yeah. I mean, if we can, I know Zig in general wants to avoid having different different sub languages, DSLs pretty much, for doing things in a language. Like for C++, for instance, you have C++, but then you kind of have like this templates language, and then you also have like the C macro language as well that you need to learn, because like you can't intuitively know how that language works just from learning like C++ alone. And then there's also like CMake, like your build system you need to know. But with Zig, you have the Zig obviously for itself. The type system seems to be again just Zig, and even the build system seems to be just Zig. So very interesting. Disclaimer. This post is meant to discuss reasons why Zig-style generics are not well suited for languages other than Zig. And again, this is really interesting because C++ might be adding some similar features soon. well, soonish. Zig's generics are in some sense well suited to Zig because they line up with the language's philosophy that it is very important to have fewer concepts rather than more concepts. hmm However, most languages don't share that philosophy, at least not as strongly as Zig does. It's also not meant as a dig at people who enjoy Zig's generics. If you're writing mostly application code by yourself or in a small team, I wouldn't find it hard to believe that you enjoy using it. Well, so is he saying it scales badly? More power to you. All I ask from you is to read to the end of this post in the hope that it will stop you from being an over-enthusiastic youngster when talking about it to other people. Um, so then, is he going to make an argument that Zig generics are actually good in Zig? Or that Zig might even benefit from not having that. I do wonder. Also, when was this posted? Can I get a date? About. Hi, Varun. Um, I actually do want to have a look at these um, posts as well. But anything zig, 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 zig. Okay, this is 2022. So this would be a decent. I mean, it's 4 years ago ish. Like three and a half years ago. So this is pre. I guess like C++ reflection. Like, I mean, obviously that's been in the horizon for a long time, but like it's really coming into light more now. Um, yeah, like I'm trying to think what was this like really happened in those 4 years. But honestly, I'm not even entirely sure. I guess Zig just in general has kind of gained a lot more popularity in recent years too. Anyway, these some interesting posts. Might look into them later. Uh, okay. So Zig generics for the uninitiated, which you can skip if you already know how they work. I don't know how it works, so this is perfect. So lack of constraints and signatures. The basic idea behind generic functions in any language is that the function declaration has one or more parameters for which it doesn't know the entire type. The typical syntax looks something like this. You have a function with your like generic type arguments, I guess, T and S, and we're saying that X is a T, Y is a okay, like a struct of S. Right. However, how do you do something such as copy data, move data, transform data with the corresponding values x and y if you don't know about what operations are possible? Right. So there are broadly two different design decisions possible here. Requires specifying what operations are possible in the function signature. These can be checked at call sites of my generic func. There are various approaches to this, like Go interfaces, Rust traits, Haskell type classes, CPP concepts, and so on. Yeah. And out of all, I mean, I haven't looked into Go. Though that is a language I want to kind of look into because it is quite popular. I mean, obviously I'm on Google and everything else. Traits is a very interesting system, um, and type classes too. But I think my favorite so far is like a cross between traits and concepts, which is it's kind of hard to explain. But like I do like these more than like I guess classes, like OOP classes or like interfaces. I like the traits or like concepts and type classes more. Don't require okay, so or they don't require specifying the operations needed up front. Instead, at every call site, instantiate the body of the function with the pass type arguments like t equals int, s equals void, and check if the body type checks. Okay, of course, this can be cached in the compiler to avoid duplicate work if one has a guarantee of purity. Uh, what does this mean? Don't require specific. Okay, instead at every call site with the past type arguments, check if the body type checks. So like just check at the call site if it's valid. Like oh you can't add two strings together. That I mean for example I mean obviously you can define it in some languages, but like if you can't add these two things together, then we're gonna give you an error. I guess that's what it's saying. But then that's more overhead at the call site as opposed to just having it part of the signature. I feel like signature's better, no, because it's just more reliable. In addition, and like easier to kind of reason about. In addition, certain operations are always allowed by default to reduce verbosity in the common case. For example, in Rust, an annotated generic parameters stands in for types which can be moved, but allowing deep copying requires an explicit clones constraint. Okay. In contrast, Swift and Go allow deep copying by default. These choices reflect different priorities and perspectives on what is needless friction versus what is useful information. When was Go made, actually? I know Rust is like, but wait, 2009. Rust was 2006. Oh wow, actually like the quite recent, like quite similar time releases, whatever. Um, Deep copying by default. Okay. Colloquially, the first group is often called generics, and the second system is called templates. Oh, I see. I do see. Okay. I mean, I feel like with templates, at least with like C++, I mean like obviously concepts use templates. Um, but I guess like the more classic idea of templates is like, yeah, specifying what the type parameters are and okay. Um, Although, like there's also type inference. So the second system called templates. The most popular, read notorious example in the second group is C++. Sometimes. The problem is that generics is also overloaded to mean any system for polymorphism. So with that meaning, it would include templates as a subset. I'm going to keep using generics in the second sense of the word. Okay? Overloaded. Okay, so what does all of this have to do with Zig generics? Zig generics are really templates, where you do not specify constraints up front, instead you write a function which takes a type as a compile time argument. Yeah, here is a code example. Yeah, okay, I thought so. PS code examples are tested with Zig 0.9, slightly old at this point. What is Zig on now? Zig, uh, current Zig version. Oh, 0.14. Okay, so got to take this with a grain of salt, but we can at least look through history here. So we got a struct. Okay, so we're assigning the struct to context, kind of like reminds me of OCaml. Okay, pub function main void optimistic x. Okay, so x is this, but like it's a type. Okay, so x is the struct type, and then this is a struct um object. Is that what you call it? Object association, whatever. And then we have an optimistic function takes a comp time t of type. Okay, and then a TT. Okay, so we're using this here. Interesting. Void standard debug dot print whatever. Okay, so I guess like the first thing that I notice here is that we're using this here. Um, which I feel like can be a bit risky. Like if you look at C++ templates, they put like the thing here, right, in the angular brackets, and then because it's before the arguments here, you don't because you have that separation, you don't have to worry like, okay, like do we know what t is at this point in the parsing, or but like here it's like already known, right? Um, Interesting. Also, type as a type. Like again with the C++ concepts, you have actually. I mean, let's have a look if I can find it. Just say concepts. I meant reflection. I think it's here maybe. No, there's like a specification for it. Um, STD meta, standard meta, constant object, constant unit name. I mean, C++ has templates anyway, so you wouldn't need to do that. But like, please, is it here? Um, Operators, splicers, info, I guess. Eh, I don't know. Anyway, from my understanding, you can like kind of Like this would allow you to pass, well, like to do something like this. Also comp time here. Comp time. So the type needs to be known at compile time. Notice how the optimistic function accesses the field f of on the parameter t, f on parameter t, yeah, without having any extra constraints in the function signature. Yeah, how does that even work? The equivalent code would fail to compile in Go, Swift, Rust, Haskell, etc. with a type error inside the optimistic function, but it would compile in C++. Really? I know that you can do this in concepts, but can you just do that like... okay. The difference between Zig and most other statically typed languages is the second camp is the language used for metaprogramming, yeah, and the flexibility you have in compile time. Okay. Can we can we just test this real quick then? In Godbolt. So C++, zoom in here. The audience. Ignore that. So let's go. Okay. So we have a struct f, and we want to access a struct without knowing the type necessarily. So what like a struct, I will call this x, and has a was it int f? I remember. Yeah, yeah, int f, whatever. Okay, and um, we have an optimistic function. So was it void? It has a template. Okay, well, so in that case, template, type name t. Okay, and what's it again? It's taking a t. Okay, fine. Um, and we're printing, right? So I'll just do stdc out t.f. Okay, so we need to include iostream, of course, and then for our main function, we're just um, whoops. For the main function, we're just doing calling optimistic with a type x on, was it x? Oh yeah, does this work, by the way? I forget what version of C++ that was added. Let's see. Holy moly, it compiles. Are you really? You can do that? I had no idea that this was possible. Wow. Yeah, okay, wow. I just learned something about C++. So if there's not a whoops, if there's not a thing there, struct X is no member. Ah, I see. Oh no, but no, like I do understand this. But like I'm surprised it doesn't check. That is interesting. Okay, because like I know concepts kind of again like do a similar thing, and I guess that it makes sense then why concepts can also do this. Because as like I'm pretty sure templates. I mean, like they're more than just a preprocessor, but it's effectively just creating a function like this. I guess it looked like optimistic x. I don't know, with an xt, and then it does this, and then because x has a member f, it's like okay, that's fine, and that's it. So these are effectively equivalent. I mean, don't quote me on this. I don't know if I'm correct, but that's how I see it making sense. Okay, that's cool. Shit. Um, Anyways, are cool. I don't know. I'm not sure I like it, but it's certainly an interesting thing. I think a type error it's kind of just better for modeling. Because like if you're looking at the function like without knowing that x exists, and like you see this t that could be any type. It's like what's dot f? Like okay, so like we're just saying it has to have a dot f. Like in that case, why would I not just wrap that in a trait? Or for C++ 2020, I can wrap that instead in a concept. So I can assert, make sure this has f. Like I guess it's like kind of the same result, but it's just a bit more clear. Like the intention is more clear. Zig's language for metaprogramming is approximately a subset of Zig. Approximately. Flexible operations like matching on types and looping over fields are easily doable with constructs that are similar to or the same as ordinary Zig constructs. Wow. So interesting then that's again C++ reflection is kind of going in this direction. Because like in that sense, that with concepts is really moving away from. I mean, I say moving away from like it was never towards like the Rust approach or the Haskell approach. But it's interesting that now people have like are like saying abandon C++ to go use Rust, and Zig comes around has this. People are like, oh, Zig's kind of cool, and now C++ is going towards that Zig direction as well. And I was like, oh, maybe we underestimated C++. I mean, it's still a very messy language, but C++ template metaprogramming is somewhat notorious for having an arcane set of rules which are hard to understand. Flexibility is possible, but with a high cost in terms of code complexity. Yeah, Circle adds a more C++-like metaprogramming language on top of C++ 17 to support imperative metaprogramming. Circle. Meta statements. Meta printf. This execution statement executes when it's parsed. Unlike a real execution statement, it doesn't need to be executed from a function. When it's parsed. We can execute when the statements in namespace scope. Okay, how? Huh? When the compiler translates source to AST. What? So like when the compiler parses this, it prints hello global. Okay, interesting. I mean, that sounds like a kind of like preprocessor, doesn't it? In a way, like, but like it's like instructions for the preprocessor or the parser. Pre-prop parser. What the hell? Okay, interesting. Terra is a systems programming language like C and C++ that allows metaprogramming in Lua. Huh? Systems in what? In Lua? Oh my days! God, God. For those who don't know, I hate Lua. I just don't like its syntax, but this is interesting. Um, okay. Okay. What's it do? I hear. Okay. Template, function array T, struct array. Right. Okay. D also allows metaprogramming in D itself. There are various talks by Ante Alexandrescu, which shows the powerful metaprogramming capabilities of D. D is a language I've been interested to look into. At first, I thought it was just like a joke. You're like C D, but no, clearly it actually has a like a genuine goal. Print dump. Let's have a look at this. We import inside the main function. Okay. Yeah, I mean, it's just used by Netflix. What, Netflix, eBay? Okay. Pretty significant. Okay. So Sig is somewhat similar to D and Circle here. However, compared to the most mainstream languages on the list, which is C++, Zig makes the experience of metaprogramming more approachable. Again, to reiterate, the list is not meant to be comprehensive. For example, Rust also has a flavor of templates now with increasing support for compile time evaluation and the ability to use compile time functions in certain generic contexts. I mean, I would hope so. I'm also not talking about dynamically typed languages here because this post is going to be too long anyways. I'm primarily concerned about statically typed languages. That's fine because that's what I'm used to anyway. Lack of state information and signatures. While Zig features compile time computation, information about when functions are available is not a part of function signatures. Here is a code example. So we have a random UA return 4, sure. Um, we have a buffer array, I think, with undefined. Get random, we catch and return 0 if it Fails? Oh, okay, get random. And then return above 0. Comp time, okay, comp time error. Even though this and this have the same signature, they do. Not both of them can be called in a comp time context. So this one doesn't work, even though it's literally just returning 4. Oh no, sorry, that's this one. This one doesn't work. Is it because like you need to declare this is comp time? I I mean I can only assume that this is the reason why. But why can't this also be made comp time? Because like I assume the compiler has access to the operating system. In contrast, C++ code attempted to call non-context-aware functions, i.e. functions only accessible at runtime, in a context-aware context, i.e. functions which are available both at compile time and runtime, will give an error at the call site. So, yep, it's a function, and this doesn't work because this also needs to be declared context-aware. You don't need to have a call to G for the error to be triggered. Rust has similar behavior as C++. Okay, why Zig-style generics are unsuitable for most languages? Okay, let's get down to the main point of this post, which is why Zig-style generics are not a good fit for most languages. One meta point to keep in mind, many of the points here mirror the downsides of dynamic typing in comparison to static typing. Again, not to imply that the dynamic typing is not sometimes useful, because in some sense it is the same problem, but it's in a different context. Instead of runtime versus compile time, we're talking about instantiation time versus declaration time. Yes, you have more flexibility to do whatever you want, but the problem is that you have more flexibility to do whatever you want. Yeah. Limited compiler support when calling generic code, or traumatic type errors when calling generic code. Okay. Yeah. Obviously that's I think that's like probably the main reason C++ is so bad with its errors. Like with and like why C in comparison is quite chill. Language designers usually care about error messages. The problem with templates is that you can get errors which are arbitrarily deep in generic code. So how does Zig handle that? A single type error can easily end up generating a generic instantiation trace that has dozens of error messages. C++ template errors are somewhat notorious for this, having known to make many grown adults weep. Most of the in-between ones are irrelevant, but they're shown anyways, because that compiler does not, and almost cannot by construction, I suppose bearing some future applications of ML, I don't know much about ML, have knowledge of which bits of the trace are actually relevant. In other words, the compiler has no way of knowing whether the error is in the template's implementation, or if the caller instantiated the template with invalid parameters, or if the error is somewhere in the call chain in between. So it needs to show the entire trace so that you can try to figure out what the true source of the error is. Right, so you get a lot of not so useful information. Added based on wording what? Added based on wording suggestion by Sandwich Today in the r/slash programming section. Oh, so did he post this? Oh my god! There's 2022. Right. Reddit looks a bit different. Um, this is so cool. I should really look on old Reddit on old Reddit more, honestly. Um, okay. Sounds like pre-concept C++. If one wants to support more complex type systems and features like high-kinded types or ranked polymorphism, okay, the complexity of error messages becomes even worse. Um, one of the factors which makes template errors in C++ worse compared to Zig is that C++ supports function overloading and other fun stuff like sfna, which stands for I can't remember. Substitution failure is not an error. Yeah. And ADL, which influence name lookup in non-trivial ways. Right. So Zig doesn't support function overloading. Interesting. Limited compiler support when writing generic code. Since templates cannot be fully type checked by themselves, and depending on the flexibility you want to allow, they cannot be type checked at all before instantiation. This means that you have two options when writing generic code, such as in a library. Right. So there's the path of least resistance, which means just write your code, write some tests for the instantiations you expect, check that work and call it done. Although that's a lot of effort because you need to write your manual test as opposed to having the type system do it for you or handle all that for you. And the path of being a good library author, which is to do the above and also write dedicated type errors for certain mistakes and write negative tests for instantiations that should fail. Okay, sure. The compiler gives you more flexibility, but what? OTOH? Oh, okay. If you want library users to have a good developer experience when they make mistakes, you need to do a bunch of extra work. Right. So, I mean, yeah. So then it's like putting more responsibility on the library as opposed to just the compiler. On the other hand, okay, of course. There's also makes noticing breaking changes in generic code harder. If you accidentally require some extra constraints, e.g., a type be comparable because you're sorting, yeah, the function signature can still be unchanged. Yeah. Okay. Hmm. Hmm. So how does Zig get away with this? Like, the lack of explicit stage information also means that converting a compile time accessible function to a runtime only function is a breaking change. Yeah. But again, there is no signature change to indicate that. Um, I assume like in the body. In contrast, such a change would immediately be flagged by compiler. Yeah, okay, yeah. Because you have to remove this for C++ or Rust, because you have to remove a const expr or const annotation from the function signature. Yeah, that's what I was thinking. But then, is this talking about Zig? I don't know. Limited type inference. Type inference in languages like Swift or Haskell is sophisticated in a couple of ways. The type checker accumulates facts about constraints about unknown types and can solve for unknown types in terms of the known types and constraints. The type checker understands how to derive constraints from one another and can synthesize complex chains of derivations without explicit handholding. Okay, this enables various patterns like iterator chaining with typed iterators, using typed representations in UI frameworks like SwiftUI. Okay, I've never used Swift, and conducting what is essentially proof cert after specifying a bunch of simple lemmas, all without a heavy annotation burden. Um, and even just like anonymous functions, uh, like not having to specify the type of those. I mean, it's kind of obvious, but it also enables more simple type inference, like relating literal types, any collection literals, and allowing argument types to influence a function's generic arguments. Yeah. The reason why this all works out is because the constraint language is constrained enough, okay, to allow making inferences and solving for variables. Making full-blown imperative programming available for metaprogramming, and getting rid of constraints means that there isn't really a good way to make any meaningful progress on evaluating type expressions with unsolved type variables. In a loose way, this is the difference between Prolog and C. It is easy to evaluate programs forwards in C. In Prolog without cut, it is easy to also evaluate the program backwards. Never used Prolog, but okay. Hmm. Hmm. Yeah. What even is imperative programming? Like honestly, because like actually, hold on. What is imperative programming? Sequence of instructions. Okay. Because like I mean, I was thinking procedural, but I'm guessing that that's also what it means in this case. Because like with step-by-step instructions, like I see imperative or procedural programming being useful for like tests. Um, but for actual like proofs of whether a type holds, it's got to be functional. Or like not even functional, but like expression um uh or expression oriented programming because then you just evaluate the expressions and that's fine. Um, anyway, a couple of examples. Okay, so a Zig issue discusses type inference in the standard library. One of the questions was when should the standard library make use of type inference for function parameters? which makes sense in the context of Zig, but would generally sound strange in languages like Rust, Haskell, etc., because type inference is always on at the language level. Most libraries don't need to do extra work to get reliable type inference out of the box. I wonder if Zig even allows type inference, or like to what extent it does, because Zig does want to have like, I mean, clear control flow, which I guess isn't the same as just like clear like explicit everything, but I do wonder anyway. The CPP standard library makes extensive use of template deduction guides as well as helper functions like makePair, which essentially acts like constructors but support type inference. Okay. I don't like, yeah, I mean, there's just so many reasons why constructors suck. There are a relatively large number of C++ resources which discuss class template argument deduction, or CTADs, indicating the need for understanding these for writing generic code, which do not have equivalents in ML family languages. Okay. Cannot distribute binary-only libraries with cannot distribute binary-only libraries with generic interfaces. Some languages like Swift and C# care about allowing binary-only libraries with generic interfaces. In a template-based system, one need to make the source code for the templates available. Sorry, is that grammar? In a template-based system, one needs to make the source code for the templates available so that calling code can be type checked. Yeah. The other alternative is to only allow monomorphic code in interfaces, or always expose generic code in interfaces, like C++ templates exposed in headers. Yeah. Yeah. Zig doesn't have this constraint because Zig is designed around whole program compilation from the start. IIUC, its error union system, requires knowledge of all possible errors up front. It does. Interesting. So Zig can't have like external dependencies that go beyond compile time? What? Dude, these acronyms are actually, I've never seen this before. If I understand correctly. What? If I understand correctly. Damn. Damn. You know what? I actually advocate for making this standard, please. That's quite useful. Examples related to binary alien libraries here. Apple distributes only interfaces for most of its frameworks in Xcode, which are available in a binary only form as part of the operating system. Okay, Swift having special place that has okay. Tooling needs to do more work. This is a very interesting argument in general, but in an IDE setting, if function signatures fully describe all constraints, one can avoid retype checking callers when only the body of a function changes. Yeah. As Matclad has written in 3 architectures for a responsive IDE, it's not the incrementality that makes an IDE faster. Rather, it's laziness, the ability to skip huge swaths of code altogether. I mean, of course, otherwise it'd just be really slow. What's this post about? Rust Analyzer. Okay. With templates, changing the body of a generic function means that the entire transitive call graph needs to, in principle, be type checked again. Yeah. Yeah. So, does Zig do this? Because I feel like this is just a mistake that we should repeat. One can try to be clever here in terms of incrementality, but the difficulty level has increased from a trivial problem to one that requires careful thought and extra bookkeeping. Even if compilation performance is not a problem, there are a couple of ergonomics issues. First, hover documentation is less useful by default unless the author of the generic code carefully documents all required functionality in doc comments. By the way, reading this, I've had this exact issue in programming C++ and VS Code, where I would have to recompile my entire program just to get the IDE to like start detecting errors again. Which at that point, like, why am I even relying on my IDE? I'll just rely on the compiler then. First hardware documentation is as by default. Yep. Um. Yep, but dot comments are a slippery slope. Again, you can try to remedy this by extracting this information from function bodies transitively, but that has its own set of challenges in terms of implementation and invalidation. Second, autocomplete when trying to call methods on parameters doesn't work well because the IDE has no information to go on in terms of what methods you expect to be present. Yeah. If you've written some generic C++ code as well as Rust, I indeed have, you probably run into how less useful autocomplete is inside generic functions compared to monomorphic functions. When arguments with templated types are involved, functionality like go to definition, type definition, and find references on method calls do not work reliably. It's true. So usually when I try to do metaprogramming or templates in C++, I do try to use concepts as much as possible because they just help the they read the compiler slash IDE just like understand what my intention is, and like it helps me as well. You know, like if I expect an STD integral, then I expect an STD integral, or like if I expect a certain class of structs, then like why would I not just make my intention clear? Inability to have non-determinism or compile time. Some languages are interested in allowing truly arbitrary computation at compile time, including non-deterministic computation. Why not? If I understand correctly, Nim falls into this bucket. Nim, another language I've not looked at. In fact, I should really add Nim to my list of languages I want to learn. Because before I forget. Do I really care though? I might care. I'll come back to that later. However, allowing information to flow from compile time evaluation. Okay, allowing information to flow from compile time evaluation to the type system introduces non-determinism in types, which is bad for quickly computing type equality, as caching results of compile time evaluation becomes unsound. Shut up. Of course, non-determinism at compile time has its own downsides generally, and one can argue that it is a bad feature to want. I mean, does that just depend on your use case? Like, what if you just want a non-deterministic result? Is that so bad? However, you'll notice that non-determinism is in some way central to most statically typed languages today, because the default hash God, the default hash table type generally does not guarantee iteration order over keys for better performance. This means that if your code is using hash tables, you cannot directly reuse it between compile time and runtime unless you factor it out to swap out the underlying hash table. The Zig issue covers an example of how allowing compile time non-determinism can be powerful in allowing some unique abilities, like building a board checker, what you know, and lazily creating a global list based on what functions or types get compiled. But it also creates problems with memorizing the results of a compile time evaluation. I do wonder what people think about a board checker in general. I've seen people say that they really like if C++ implemented a board checker, and I wonder if the same can be said for like Zig. Notice that the suggested fix essentially involves making compile time evaluation semantics diverge from runtime evaluation semantics. Okay. Inability to support polymorphic recursion. Some languages support polymorphic recursion, which means that code can be instantiated with successively varying generic types. It is arguably somewhat of an esoteric feature, albeit see answers to this question for some use cases. Okay, might as well. Let's go. Sometimes you want to encode some constraints types, so they are enforced at compile time. For instance, a complete binary tree. Yeah, yeah. Like trees are kind of just like the biggest example. Can you implement a tree in this way in C++? I'm curious actually because this is quite nice. Um, Esoteric? Like, is that esoteric? I feel like it has actual uses. Or maybe I misunderstand what it means by polymorphic recursion. This drawback is shared by other languages, which use monomorphization as a compilation strategy, which includes both Rust and C++. It is not possible to reconcile templates with polymorphic recursion because templates require that all instantiations be type checked. So you need to prove an infinite number of properties in finite time. Yep. Zig allows for compile time reflection, as C++ will soon, which means that you can essentially branch on instantiation depth, so you can't necessarily prove such properties reliably. The other point is, even if you get rid of compile time reflection, proving an infinite number of properties at once essentially requires building a constraint system to infer what is a higher order for all constraint from sets of simpler constraints. So now you've arrived what closely resembles a system of type classes, but uh, which can only be used by your type checker. Huh? I didn't understand this point. Like, as opposed to what else? The programmer? But the programmer activates the type checker. Closing thoughts. If you ever see someone advertising a language feature as everything is an X, your first reaction should probably be healthy skepticism rather than delight. You can have both. Programming languages generally tend to draw distinctions between distinct things for good reasons. Distinctions between distinct things for good reasons. Um, what? As opposed to, sorry, what? Everything is an X. Well, like everything is a monad. Like that's just false. I don't understand. The C++ committee had added concepts after decades of pain with templates. I think concepts was C++ 20 or 17? 20, so quite recently. And I love concepts. I love concepts. I hate programming without them. Pain in the ass. Even if these do not overcome all the problems mentioned above, I would not be surprised to see Zig add a similar system, likely with its own twist to it at some point if it keeps growing in usage. So to wrap this off, then, does Zig have C++ concepts? Rejects it. Uh, Unlike Rust, Zig isn't a clean C++. Okay, let's have a look at this real quick then. Um, okay, I thought it'd be like an article. uh, okay, Zig generics. Is this still true? Learning Zig generics. Okay, in the previous part we built a. Sorry, I think I'm probably covering this. Hopefully not. In the previous part, we built a bare-bone dynamic array called intList. The goal of the data structure was to store a dynamic number of values, although the algorithm we used would work for any type of data. Many languages implement generics with special syntax. With Zig, generics are less of a specific feature and more of an expression of the language of what the language is capable of. Okay. Com time length to usize. Okay. Type. Return struct with an items and length. So you need to like match this layout, I guess. It might seem odd, but arrays type is really an int array 3 to type like any other type. So it hasn't changed, I guess. Okay. I don't know. Interesting. I guess to better understand this, I need to actually try programming in Zig myself. Um, but hey, that was some interesting insights. No idea if this is like a good viewpoint. Um, but I guess I can evaluate for that for myself if I learn more about the thing. So that was the article. I definitely want to have a look at these. I think because talks about type systems in general are very interesting. So yeah, awesome. Um, yeah, generics. So once again, I mean I've mentioned like C++ 26 reflection like quite a few times in this video. I do I don't know if it'll be good, like good for like in the long run. Um, I mean it'll be good for reflection, but like I don't know how good it'll be for type systems. Hmm. But definitely it will be powerful. and it'll be interesting to have an alternative to the current template system. Um, yeah, interesting. I mean, me personally, I just because Rust has traits, Rust is a language that I want to shift towards, kind of moving away from C++ as my main language. But for that reason, I like that C++ is doubling down on this, at least like in this case, on its approach to generics and reflection, and yeah, it'd be really interesting to see how the two languages compare then, like Rust and C++ and Zig. But like, I don't know. I don't know much about Zig. I don't know how far it'll actually get. I feel more like at this point C++ is positioned to kind of implement the features that Zig is aiming for anyway. But maybe that's a terrible take, and I just don't understand what I'm talking about. Again, I've never used Zig even once. Um, but that's my impression so far. I'd love to come back to this in like 5, 10 years when all these C++ features are finally implemented, and 20 years when Zig finally releases 1.0. But anyway, nice. Subscribe for more programming stuff.